All right, so I'm going to do a little experiment. I don't have PowerPoint slides, it's all live. What I'd like to do today is expose you to the same tools that the medical students were exposed in that workshop. Many of you are looking at your cell phones instead of paying attention. So now all of you can look at your cell phones and put this link there. So bit.ly app evolve. And what we are going to do in the next 15 minutes is that we are all going to get a little bit out of our comfort zone. That's true for me as well. I'm using a machine I don't understand, an operating system I don't like, and someone behind the curtains keeps flicking things. So we'll see if this is all going to work. The point I want to make, so you get a single page with lots of links, and I'll be clicking on the links as we go. The message is very straightforward. I think it's actually very easy for people to understand today. It wasn't so easy a few years ago. That our digital neighborhoods, they are partially decoupled from our physical neighborhoods. And the data is flowing between our digital neighborhoods in ways that we are only now starting to understand. This was not designed. It's happening in response to forcing functions that are not always clear to us. Sometimes they are financial, sometimes they are sociological. So the summary is just 2 lines. Health data landscapes, and the title of my presentation is kind of weird, right? It's app evolution in real time. So let's see if I can unpack that. So health data landscapes are growing quickly. All this data we provide is going all sorts of places. Some of them are public, some of them are semi-private, and some you don't know. And the second point is that this is the one that is, I'd say, more cutting edge, is that data became available much faster than our ability to analyze it. So even today, we are only looking at the very tip of the iceberg of the amount of data we could be using, for instance, to create risk assessment tools on the fly. So these web ecosystems are now being populated by web applications. So when you're using an app, this is a web page that is packaged in a way that can live in your devices, and each of you has a different device, and you'll see that the application is not bothered by that. What I'll try to show you today is that these applications are pieces of code that will go to the Department of Health, they will go to your wearable devices, and they will go to your patient encounters. And you may be surprised to find out that not as much of it is not public. And so this is giving us amazing powers of observation. The older people in the audience probably know where this link goes to. Don't click on it just yet. Do it after the presentation. So we want to see the forest as scientists. We want to see the trees to personalize the science we are developing. We want to see individual trees if we are caregivers, so the person that is in front of us. And then there are many, many stories that are coming out of this ability to traverse this data landscape. So let's start with the forest. I'm just going to open the links. I'm not sure how fast the machine is, so I'll just leave them open. So the forest, the trees. Oh, it's loaded pretty quick, so you can do it. So this is the forest. Suffolk County. Yeah, I got it. And what you have here is different conditions. You can now check this in your devices. So the first one is some general composite scores for quality of care and quality of health. And then you have things like COPD, heart disease, and a number of pneumonia, and hypertension, dehydration, and so on. And here you have the observed value and the expected value. We have the position in space, we have the position in time. So I'm not going to run the clock. You could click on individual places and get the representation just for individual place, for individual disease. So I'm now going to let the clock run. So we are now looking at the forest. So here we go. So here you have observed values for each of these conditions. Then you could say, I only care about COPD. You would click here. And you could say, I'd like to see the data. We always want to see the data. There it is. And you could say, well, actually, I want to see everything. And you see the table changes automatically. So there is a science point I want to make behind this. It's not just the graphics. So what you see here is that the values mostly go up and down, see, up and down, except in 1 year. So this is the expected value predicted by the Department of Health, and this is the observed value. So let's go up. There is 1 year where things are going to move sideways. It's this one, 2014. So what happened is that in 1 year, the Department of Health of the state of New York decided to play with the predictive models, and it moved the goalposts. Suddenly, everybody was doing poorly, and only a few people doing bad, which is not the purpose of these scores. The purpose is that half is green and half is red. So the people that are red are penalized or are helped. I don't know what exactly they do with this information. Now, the important point of all of this is that I'm just delivering in your digital space something your eyes can consume, but at the source of all of this is the types of links you've seen in the previous presentations. You have health.data.newyork.gov and so on. So this is the public branch of the data that we are generating as patients and as caregivers and as biostatisticians that is being delivered. Okay, so you've seen the forest. Now I'm going to go quicker. So here I'm going to reload so you see that this is really scalable. There we are. So we have around 20 million patient encounters. And if I say something that sounds weird, I put the two publications here, so you just check the publications. You'll get more information there. So see, the forest is still moving around, and we just ignore it and move on. So the code is going to where the data is, and it's doing funny things, even if you're not looking. So I go here, I have all these diseases. I'm looking at Suffolk County in 2015. We heard about lung stuff before, so I'm going to put lung, and we get 2 types of lung problems. Again, in real time, this is us. You could change here, you could go up and down. And this is 20 million patient encounters. So it's a lot of data in a machine that was not configured for this. So this gives you an idea how close this decoupling between your physical location and the computation in your devices is. Your devices are much closer to each other than you are to those who hold them. And this sort of scalability is pushing us to this amazing powers of observation I mentioned in the beginning. So there are many stories that are coming out of these sort of studies. For instance, we could do cancer. You'd get all the cancers. You could find out, for instance, what cancer patients from our neighborhood are moving away. I'm just going to click on one of the numbers here. For instance, we have 212. Oh, this is breast cancer. So I'm going to click on it. So see, now I have this, there's a moment of pause because the data is migrating from the Department of Health to something that looks like an Excel spreadsheet. And now I'm going to move it to Google. Notice how these things are happening seamlessly. In the interactive tools, they are happening automatically. Now I'm making it happen manually. And why I entertained you with a couple of words, Google said array, right? So what do you mean array? It means that the machine learning engines of Google kicked in and analyze the data for salient statistical features. So now I could find out, I don't know what this is. Oh, this is age groups for breast cancer, and sure enough, older age groups are more prevalent. But you also, so you have the ability now to engage statistics in a way that would be unthinkable before. So these machine learning tools are going around and doing this. Before I move on, I want to show you the data. I always like people to see the data. So let's move to 2015, something more recent. I'm going to show you one of the links, and then this is for you to think. I don't know exactly what to think about this. So I'm going to put it here. And by the way, the paper has examples of this. There it is. Instead of CSV, I'm going to put it in a format where you can see the names of the fields and the data. Okay. Now, you have one of the 20 million patient encounters. Just have a look at the information that is provided there. And notice the following, that some things are not shown for privacy, so we don't have the patient's phone number. But other things are exposed because there is no privacy associated with them. And for the medical students, this is particularly important. There is no privacy associated with caregiving. So there's a full track of your activity as you go on. And I'm about to run out of time, so let me go straight to one of these stories, which just came out, right? Many of you saw this. So this idea that we can look for quickly, on the fly, for things like poison. I'm assuming you can map it over time. I'm assuming opioid would be here, right? And you have the information. So now we could go get the patients and the physicians that are treating these patients. As you saw in the plot of the data, oh, it's here. Where is this? Patient disposition. Somewhere here where the code of the physician. You have the total charges, so that's also interesting. Just give me a second. Oh, there it is. Attending provider license number. So there are databases that now describe your trajectory as physicians under these sorts of references. So we're only left with one thing, which is this idea of one tree. So we saw the forest, we got excited, all these things moving around. Then we got worried about the insight we get with the trees. But now we are in the situation where we are treating someone, a single person. And the digital neighborhood of single people is also growing very quickly at all levels. The genomic information is now available in consumer-facing companies like 23andMe. So you can talk to remote repositories of your data, like these consumer-facing genomics shops, but also wearable devices. So I'm wearing one of these cheap Fitbits, and I could say, okay, let's connect. Again, this is a web page, a machine I don't control, and I'm going to try to go from here to my wrist. So I want to connect. So see, no tricks. I'm not logged in. This could fail if I forget my password. Oh, I didn't forget my password. Okay, so I went in, and there you are. So they have the information about my mobility, heart rate, and so on. So I'll stop here. You saw going from the forest to the moving trees to the individual person. It's up to you guys in the domain to make sense of this. What we do in biomedical informatics is expose these things to you. Our biggest limitation right now, by far, is human resources. So it's the ability for people from the domain to walk into an academic domain. So I put this in the slide that the science and the care are closer to each other than ever. And I would challenge the medical students to get out of their comfort zone and come meet us, because we'll make our effort as well. Sometimes I hear this comment that I don't feel like learning how to program, especially not in web technologies. So remember, those of you with children in Three Village School District, say in Ward Melville High School, that's what your younger siblings are learning. So if you don't do it, your younger siblings will do it. And I'll stop here.